So, keeping on with day 72 notes, are basically, they're just practice problems that we're going to work through together. When we're solving by taking square roots, we need to get our variable that's being squared by itself on one side of the equal sign. So we'll just do numbers 3 through 6. Each one's just set up a little bit different. The key here is we're going to be using our algebra skills to get that variable by itself before we do the square rooting. If we look at number 3, we've got 25p squared equals 4. Well, p squared is certainly not by itself, so I'm going to divide both sides by 25. And I get 4 over 25. And I know that that's a fraction, and I know you don't like it, but that's okay. So now I'm going to square root both sides, and I get that p is equal to plus or minus the square root of 4 over 25. And that's correct, it's just not simplified. So if you type that in a calculator, it's going to give you a decimal, and I can live with that. But we know how to square root 4, and we know how to square root 25. So I'm going to do it as a fraction. Well, the square root of 4 is 2, and the square root of 25 is 5. So I would write it as p equals plus or minus 2 over 5. If you type this in a calculator, it's going to tell you that p equals plus or minus. Actually, the calculator will not tell you the plus or minus. You need to make sure not to forget that piece. But 2/5 is 0.4. So I would accept plus or minus 2 over 5. I would also accept plus or minus 0.4. Don't be afraid of fractions. If we look at number 4, we don't have a squared by itself. We have 2a squared plus 1 equals 9. But we've had a lot of equations where we've had to solve for our variable, so we just keep following those algebra skills. The first thing we're going to do is subtract 1 from both sides. So we get 2a squared equals 8. Then if you divide both sides by 2, you get a squared equals 4. And now we have our variable squared by itself. So if we square root both sides, we get that a equals plus or minus the square root of 4. But we know that the square root of 4 is 2. So here we're just following those steps we would in solving an equation if this wasn't an a squared, and then we're going to use the square root function. But subtract the 1, divide both sides by 2, and then instead of just having a equals 4 like we would in the past, now we have that extra step of taking the square root. So if we square root both sides, we get that a is equal to plus or minus the square root of 4, which we all know is 2. Okay, moving on to number 5. So number 5, I know I folded that in half, but you guys can see it. The plain sheet, if you didn't download it, it is further down on the page, so you can open that up. We've got negative 3 minus 2x squared equals negative 25. Again, our x squared term is not by itself, so we're going to get that alone before we worry about taking the square root. So hopefully this gets smushed together with the other video since I ran out of storage. Anyway, number 5, negative 3 minus 2x squared equals negative 25. Before we can start solving for x, we need to get it by itself or get the x squared by itself. So the first thing I'm going to do is add 3 to both sides. When I do that, I get negative 2x squared equals, well, negative 25 plus 3 is negative 22. And then I'm going to divide both sides by negative 2 because I'm trying to get the x squared by itself. So I get x squared equals 11. Negative 22 divided by negative 2. Remember, negative divided by a negative is a positive. So I get x squared equals 11. If I square root both sides, I'm going to get x equals plus or minus the square root of 11. Well, you can type this in your calculator and it's going to give you a decimal, and you know how I feel about decimals, so we are not going to write the decimal approximation of square root of 11. We want to look and see if square root of 11 has any perfect square factors. Well, 11 is prime. It's nice because it's pretty small, so we don't have to do a lot of work to figure out if it has perfect square factors, but it doesn't. So we just have plus or minus the square root of 11. And that is the answer I want you to give me. I do not want you to type it in your calculator and then round that decimal. I want you to leave it as the square root of 11. So here we had to add 3 to both sides, divide by -2, and then take the square root, because we have to have the thing that's being squared by itself before we can take the square root. Notice I said the thing that is being squared, because if you look at number 6 is not a single variable being squared. It is a quantity that's being squared. So a lot of you missed this problem on the quarter 3 exam because you wanted to bring this exponent into both pieces. You cannot do that. This is not going to help us with this problem right now, but just to remind you, 2n minus 5 quantity squared is 2n minus 5 times 2n minus 5. It is not 2n squared minus 5 squared. You cannot distribute a square. So it is that quantity times itself. And a lot of you missed that on the quarter 3 test. Anyway, back to what we're trying to do today. Today we're not trying to multiply it out. Today what we're trying to do is solve for n. And since I have this quantity squared, and it's all by itself, the thing that I am squaring is by itself, I can go ahead and square root both sides of this equation. When I do that, I get 2n minus 5 equals plus or minus the square root of 100. Well, we know that the square root of 100 is 10. So we get 2n minus 5 equals plus or minus 10. And that is a weird looking equation. We've never had something 2n minus 5 equals a plus or minus. Well, that plus or minus is just telling me that there's two answers. It means that it could be positive 10, because positive 10 times positive 10 is 100, or it could be negative 10, because negative 10 times negative 10 is also 100. So what we're going to do is break this apart, kind of like we did for absolute value equations, which I know you've slept and you might not remember, but seeing it broken apart like this might make you remember, because this says 2n minus 5 could be positive 10, or 2n minus 5 could be negative 10. And those should both look like equations you're comfortable solving. Here we add 5, and I get 2n equals 15. Divide both sides by 2, and n is 15 halves. I am going to leave it as a fraction. You could type 7.5 or put it in your calculator and get 7.5, and I would live with that. I'm not going to. If we solve the second equation, we add the 5, and we get 2n equals negative 5. Negative 10 plus 5 is negative 5. Divide both sides by 2, and n is negative 5 halves, which I will also leave as a fraction. If you put negative 2.5 because you typed it in a calculator, that would be okay. So here, if you didn't put the plus or minus, you would only get one answer. It is imperative, that means very important, that when you do these square root equations and you're taking the square root of both sides of an equation, that you always add that plus or minus over here. That's got to show up because we've got to have two solutions. So I think these are way better, maybe not better, a little easier than the quadratic formula. The quadratic formula always works, which is what makes it phenomenal. It's just a little tedious. Sometimes if you've got a problem that's set up like these, you're going to be able to do it a little bit easier just by taking square roots. Okay, the last two problems on the notes for today are review, so I'm going to do those in their own video.